Fault Finding, Lesson 2, Test Instruments. Each slide in this lesson will have a video and a description, followed by a number of questions. Answer the questions in your own words as best as you can. If you're unable to find all the answers, go back to the previous slide and watch the video again. You'll need to pause the video in order to answer the questions. In this lesson, we're going to state the requirements of Guidance Note 38. We'll discuss the safe use of test instruments and assess the risks when using hand tools and power tools. Risks of injury from electric shock are increased when fault finding. This is due to live conductors potentially being exposed during the investigation process. Other risks that exist when fault finding include damage to tools, equipment and property. In order to reduce the risks associated with fault finding, electricians follow the safe isolation procedure to remove power from all or part of an installation. The level of voltage that is considered to be dangerous is anything above 50 volts AC or 120 volts DC. Some test instruments use voltages far in excess of the safe lower voltage. An insulation resistance tester, for example, will often expose a circuit to 500 volts. This is intended to stress the installation of a cable to check for potential leaks of electricity. This is similar to a plumber pressure testing a pipe to ensure there are no gaps that may leak water. Other test instruments are intended to be used while the installation is energized or live. In this case, an earth fault loop impedance tester, respective fault current tester, or RCD tester, will apply a small current to the CPC and the MET, or circuit protective conductor and main air terminal, which would normally be at 0 volts. Any break in the protective conductor will produce a voltage on the tail that is disconnected from the main air terminal. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. Guidance Note 38 is produced by the Health and Safety Executive, or HSE, as a guide to the use of electrical test equipment used on low voltage systems. It is intended for use by electricians, electrical contractors, test supervisors, technicians, and appliance retailers, and includes advice about the selection and use of test probes, leads, test lamps, and voltage indicating devices. As a simplified look at some of the guidance contained in GS38, the probes in particular must have finger barriers or have a molded grip to prevent the hands from slipping and making contact with the live conductors under test. They must also be insulated, leaving only an exposed metallic tip, which should not exceed 4 mm in length. It is recommended that this be reduced to 2 mm or less, or ideally, they should have spring-loaded retractable screened probes. A multimeter, that is, any test instrument that performs more than one function. The probes should be fused to prevent current exceeding 500 milliamps from flowing through the device. An exception is an earth fault loop impedance tester or an RCD tester, which are intended to be used on a live circuit. They can have a value of up to 10 amps for testing purposes, but these instruments will be further protected internally to protect from shock or explosion. The test leads, that is the wire that connects the test instrument to the probes, should be fully insulated, not allowing for any exposed conductor along its length. They must also be sheathed to protect against mechanical damage. This means that the leads must be double insulated. They should be coloured so that the leads can easily be distinguished from one another. One exception is the voltage detector, which tends to not have different coloured leads. The leads must also be flexible and of a sufficient capacity for the voltage and current that it is likely to be exposed to. And finally, they must be long enough for the purpose, but not so long that they become clumsy. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. As we saw in GS38, Voltage detectors have slightly different requirements than other test instruments, but they are the most important test instrument for an electrician to carry around. The types of voltage detectors available fall broadly into two categories. The first is an illuminated indication, for example a test lamp or a voltage lamp. The other is a scale indication or voltmeter that you might see when using a multimeter. If using a test lamp that is fitted with a glass lamp, it should not expose the user to danger if the lamp is broken. Consider the implications of a smashed light bulb and a light fitting. With the power still connected, simply touching the exposed terminals can cause a serious electric shock. All these detectors require protection against excess current. This protection is usually provided by an HBC fuse, that is a high breaking capacity fuse, or an HRC fuse, which is a high rupturing capacity fuse. These will be housed within the probes themselves. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. It is vital when using test instruments to understand how it works. You must know what you are testing for. Is it the voltage, current, or resistance? You must also know what you expect the result to be in order to select the correct scale. This can be a major stumbling block for new electricians when learning about the different methods of testing and fault finding in installations. You must make sure that you are familiar with the instrument to be used, its settings and scales, and the tests it can perform. Consider its range, span, and resolution, and check its suitability for the installation that it will be used on. Is the installation a low voltage, that is anything between 50 and 1000 volts AC or 120 volts and 1500 volts DC? Or is it extra low voltage, that is anything less than 50 volts AC or 120 volts DC? Some commonly used testers for dead wire testing include the continuity tester, used to test resistance less than 2 ohms, the voltage meter, required for voltage between 50 and 1000 volts AC, and insulation resistance testers for measuring high resistances above 1 megaohm. There are also test instruments for use on live conductors, including the earth fault loop impedance tester, which measures impedance, which is similar to resistance, but includes reactive components. PFC tester, which measures fault currents in the thousands of amps range or kiloamps. And the RCD tester, which records tripping times in thousands of seconds or milliseconds. Calibration is required of all test instruments that are intended to be used for measuring and recording test results for initial verification or inspection. These test instruments should be calibrated within a time period of 12 months. This must be done under laboratory conditions where they are measured against standards that can be traced back to international standards. A calibrated test instrument will have a certificate dated and stamped that should be kept for reference purposes, and it will have a label attached to it spanning the seam, stating that the date calibrated and the next calibration. If the label is damaged or missing, the test instrument must be sent for recalibration. In order to ensure the reliability of the tester, it must be maintained well with the leads in safe working condition, stored in dry conditions, and if it is ever dropped or otherwise damaged, the tester must be sent for recalibration. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. Section 7 of the Health and Safety at Work Act requires employees to take reasonable care of themselves and for others who may be affected by their work. This sounds very similar to the Regulation 4.3 of the Electricity at Work regulations, but this time it is related to the use of tools and equipment rather than working specifically with electrical systems. In order to follow this law, all employees must cooperate with their employer, and the point is further confirmed in Regulation 14 of the Management Regulations, which requires employees to use equipment in accordance with the instructions and training. In order for employers to follow the law, employees are required to report to the employer any dangerous situations. You will be expected to own your own hand tools. As a general guide, you will be expected to have a range of insulated screwdrivers, pliers, side cutters, wire strippers, and cable strippers. You'll also be expected to have crimpers, a hacksaw, adjustable spanners, a hammer, and a number of different chisels and files. Each of these hand tools presents a different hazard, which may result in blows and cuts to the hands or other parts of the body. Also, eye injuries due to the projection of fragments or particles, sprains or strains due to abrupt movements, and an oversight while working could result in contact with live conductors. This is why a number of the tools are expected to be insulated. Injuries while using hand tools are usually the result of inappropriate use of the tools, using faulty tools, or tools that are not being well maintained. Sometimes the use of poor quality tools, often called chocolate tools, not using PPE, that's personal protective equipment, and on occasions when a job is not well planned, unusual postures that held for an extended period of time can cause damage to muscles and joints. In order to prevent the injuries that were discussed previously, you should always look to use the correct tools for the job and check that employees and colleagues are properly trained. The hand tools that you have should be insulated to IEC 60900. You should always use PPE, including goggles and gloves, particularly when working with sharp tools. You should maintain your tools properly. Check the state of the handles, insulating coverings, and always store and transport tools in tool boxes. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. For this task, you must complete a risk assessment for the use of hand tools when asked to install a new socket in a kitchen. Almost 25% of reportable accidents on site involve portable electrical equipment. Most of these injuries have been caused by electric shock. It is often required that portable appliances are tested once a year. This is called PAT testing. Each appliance is given a label to say that it is safe to use. This does not mean that it should not be checked again before each use. Portable appliances present an electrical hazard when the lead or casing is damaged or if the plug is not fitted properly. Use of damaged, defective, or unsuitable equipment can present a hazard if there are rotating parts that may allow materials to be projected towards the body. Lack of effective maintenance can allow tools to deteriorate and fall apart while in use. Misusing equipment can result in tools becoming damaged, or the intended protective parts may be made ineffective. Unauthorized use of equipment by employees presents a danger if they are not trained in the safe use of that item, or sometimes if the item has been removed from service due to age or damage. Use of power tools in harsh environments like construction sites, where there may be heavy foot traffic or other equipment being used in the area at the same time, that may affect its use. For example, using a drill may interfere with communication when other people are moving heavy loads. To reduce the chances of an injury on site, you should practice the correct selection and use of equipment. Ensure that employees are trained in the correct use of tools. You should maintain all power tools properly and PAT test regularly, keeping the test records for reference. And always remove damaged equipment and prevent them from coming back into use without being properly repaired. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again. We've already considered PPE, but as a more detailed introduction, PPE is covered by the Personal Protective Equipment at Work Regulations 1992. It includes all equipment intended to be worn or held by a person at work, and which protects them against the risks to their health and safety. An employer will be expected to provide helmets, gloves, eye protection, high visibility clothing, safety footwear, and safety harnesses. The employer is responsible for providing, replacing, and paying for all PPE other than hearing and respiratory protective equipment. However, as an employee, you will be expected to keep this equipment in good order. Answer the following questions based on the previous slide, using your own words. If you struggle to answer any of the questions, go back to the previous slide and watch the video again.